Good morning, good evening, and good afternoon. Welcome to the technical session 3B of 4th International Conference on WS4. Due to COVID-19, we all are going through a new normal phase, and the team of WS4 wishes you a very safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at a different level. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received tremendous number of submission, which has across more than 700 plus number and 20 plus countries marked through direct submission and special sessions, out of which 142 papers were accepted by the Technical Review Committee. Once again, we all would like to congratulate you for your research work and to be a part of this success story in a fourth version of this conference. Further, I would like to welcome our session chair to take on this session, Dr. Parikshit Mahale. He is a professor and head of department, Sri Kashibai Navle College of Engineering. He has a more than 18 years of teaching and research experience. His subject of interest include theory of computation, system software, data structure and algorithms, principle of planning programming languages, computer networks, and network security design, and analysis of algorithms. Welcome to you, sir.
Thank you.
Now, sir, please start the session.
Now I would like to invite our first presenter, Abdullah Ali. Abdullah, I am unmuting you. You can just go ahead with the presentation.
Thanks, Prof. Okay, I'm here. Good evening, everyone. I'm Abdullah Ali. I have BSc and MSc in Electronic and Communications Engineering. Here, share my screen. Okay. Our research is design and implementation of compact dual mode bandpass filter using fractal geometry. Here the outlines of our presentation. Aim of work: technologies for implementing microwave filters, fractal geometry. Here we will give an introduction and basic properties and some examples of fractal geometry. Electrically coupled resonators, bandpass filter based on more fractals. Unstep-loaded electrically coupled resonators, bandpass filter, fabrication and measurements, and finally is the conclusions and comparison with previous studies. Aim of our work: the intended aim is to design microwave bandpass filter for WLAN applications. And we know that the bandpass filters in modern or all the transmitters and receivers of communication systems, it's very important in order to pass the required region of the signal and reject others. So the intended aim is to design bandpass filter for WLAN applications having the features of low insertion loss and high return loss. The insertion loss has a normal region from less than 3 dB, but the return loss should be more than 10 dB. So the filter will operate if it's between the insertion loss lower than 3 dB and the return loss higher than 10 dB. Also, the other feature is linear phase response and flat group delay in the pass band. And this very, very important note to show it. Then, the reduced size and weight in order to integrate easily with other components as a single chip system and low cost. And here the cost is very important because everything nowadays should be in a low cost. We will use more fractals and sublet resonators in our research. There are many technologies for implementing microwave filters. From these technologies, microstrip lines, integrated circuits, high temperature superconductors, microelectromechanical system, or called means, metamaterials, and the wave guide. All these techniques has its region of applications with specific properties. But in our research, we will use a microstrip line structure with a fractal geometry technique. So we will give an brief introduction to fractal geometry. The fractal geometry can be described as a fragmented geometric shape that can be split into parts, each of which is a reduced copy of the whole. Then, all the fractal geometry has two basic properties. These properties is a self-similarity and space filling. The figure here is illustrate the properties, which is a square, original square with a side length L. The fractal geometry construction process will begin with this central square with side length L over 3, which investigate the self-similarity and the reduced copy from the original shape. If we continuous with the construction process, then 8 smaller squares with side length of L over 9. This will be around the central one, and so on. If the process continuous, all this small squares will fill all the space, and that investigate the properties of fractal, which is self-similarity and space filling. Here we will take as two examples about the fractals is Sierpinski carpet, which is the figure we said previously, and the Sierpinski triangle. The Sierpinski triangle is different from Sierpinski carpet by replacing the square by the triangle. So we say here at first 3 iterations. If we take another 2 examples about the fractal curves, is the Cook curve and Moore curve. Here's the 3 iterations, first 3 iterations of Cook curve. This I0 is the initiator, and I1 is the central segment is replaced by this triangle, and all the 2 iterations. In our study and this research, we will use the Moore fractal, Moore curves, with this initiator and I0, I2, and I3. So, why we use Moore curve? Because it has a high dimensionality, which is 2, and that's bigger than Cook and all the other fractals. This is the base of our design, which use electrically coupled resonators bandpass filter based on Moore fractals. The first one here is the 2 resonators electrically coupled with this S1 as a gap between resonators, and that use CST microwave studio implemented with FR4 substrate of height 4.3 and dielectric constants, or ER, is a 4.3. The dimension of this designed and simulated filter is a 12 millimeter with 9 millimeter as a height and width. When we applying a first iteration of more fractals, we obtain a smaller and reduced size filter with a dimension of 9 millimeter and 6 millimeter only. But the gap between resonators is directly affected the filter response. So we will see the effect of them. The effect of gap between resonators, this is S1, on the filter response. So we observe that the S1 from point 1 to 0.6 with this dotted curve is the S11, which is the return loss. Here, these two values with the red and blue curves is the best result. On the insertion loss, this bold curve, the red and blue one. So the value of S1 will be between these two values, which is 0.6 and 0.433. Now, we have a good passband characteristic here, but the out-of-band rejection level is bad, so we need to enhance it. Therefore, we use these radial stubs, this one and this one, and open stubs, this one and this one, to enhance the out-of-band rejection level. So when we use the filter without any stubs, there are a problem with out-of-band, and specifically in upper region of the out-of-band. But when we add these stubs, the results was enhanced and improved.
Sorry for interruption, dear presenter. You have last 2 minutes. Please
Okay.
conclude.
Okay, out. This is the final result in our design, which has a low insertion loss, 1.5 dB, and high return loss, which is more than 15 dB, and operate at 5.8 gigahertz. Here's the fabrication and measurement, which has a good acceptance between them. Our conclusion is a compact site design filter with 8.83 millimeter as a length and 6 millimeter width, and S11 is a 15.8 dB, and S21 on insertion loss 1.5 dB, linear phase response and flat group delay in the passband, and wide bandwidth, it is 742 megahertz, or 12% as a fractional bandwidth, which make it suitable for wireless LAN application. Here's the comparison with the previous studies. So all the compared filter has a bigger size, but our filter is the smallest one, and that's everything. Thanks for listening.
Am I audible?
Yes, sir.
Yes. Can you tell me about your overhead of your entire work? Hello? Am I audible?
Abdullah, are you audible? The comment of the chair?
Okay.
Yeah. Can you comment on the overhead?
Please, I don't understand.
Yeah, can you comment on your overhead? Actually, you are adding one layer. So can you comment on the overhead? What extra additional cost in terms of computation?
Can I back to my presentation or what, please?
Yeah. Can you? Am I audible? Hello.
Sir, you
Voice
are
not clear,
audible.
please.
Yeah. Can you comment on your additional cost as you are adding one layer on the top of that? Can you comment on what cost it is incurring? Computation.
Okay.
Hmm.
Okay, we use the CST in CST Microwave Studio in a
Okay.
software
Okay.
and the
Hmm.
platform. And okay.
No, no. What I am asking, can you just am I audible?
Yes, sir.
Hello.
Sir, you are audible.
Yeah.
The
Abdullah
sound is
sir.
not clear. The sound is not clear, please.
Yeah. Am I audible now?
Still, it's
Hello. Yeah.
unstable.
Yeah. All competitions which you are performing, can you just comment on what is cost additional in terms of computation?
Can I place to my PowerPoint to a specific slide?
Hmm?
Abdullah, we can do one thing, sir. You can write this question to the chat of Abdullah, so that will be better to answer.
Okay. My question is very clear. Can you
Yes.
comment on what additional cost in terms of computation?
Which one you mean? Which one? Which competition you mean?
Computation in terms of processing.
You mean the resonator slide
Yeah,
length
yeah,
and
yeah, 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 yeah,
okay. It's using
yeah,
parametric
yeah, yeah,
using parametric study from
yeah,
a
yeah, yeah,
CST
yeah,
program.
yeah, yeah.
Yes, and we have the length of electric length. We make it longer according to relationship beta L equal to 2 pi L over lambda. So when
Okay,
beta L is being high, the
okay,
lambda will be lower.
okay, okay. And what about the complete solution when you will apply? What is the durability?
Please,
Hello,
I don't. Uh,
hello.
I
Can you
hear you,
hear me?
but
Can you hear me?
I don't understand your question, please.
What is the lifetime of your solution?
About 15 minutes.
50?
15.
15 minutes. Okay. Okay.
Yes.
Okay. 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 No. No. Okay. Got it. Good. Good. Nice work. Yes.
Thank you. Thank you very much, sir. Thank you.
Yeah.
Thank you, Abdullah. Now I would like to our next presenter, Love Gupta. I has already unmuted Love Gupta.
Yeah, I'm here. So let me share my
Yes.
screen.
Yeah, please.
All right. So hello, everyone. I'm Love Gupta, and I work. So I'm working in UMSL, University of Missouri, St. Louis, in the U.S. As assistant professor in computer science. And my areas of research are AI-based cybersecurity of multi-cloud applications and services, like emergency healthcare, and also performance and reliability of carrier services instantiated over multiple clouds. So these are the areas I'm currently working in. Today's presentation is on cybersecurity of critical services using a method that we have evolved using deep neural networks. And I'll share some learnings from application of neural networks in ambulance-bound patients when the patients are moved from their homes or wherever they are and they become sick, extremely sick, and they are moved to the hospitals. So what transactions take place and how do we secure those? So if there are any offline questions, you have my email below if I'm not able to complete all the answers. Um, so I have made the presentation brief to fit in the time. I'll give a little bit of background and what problems the systems pose and the proposals that we have made. Observation results, some of them I'll share today, and conclude with what needs to be done more in this. So basically, we know that everyone knows that every nation defines and builds and safeguards their critical infrastructure. So you can see some icons here. So it depends on the countries to define their infrastructure, but generally you have healthcare, telecommunications, emergency health services, water services and stuff, transportation. These are usually defined as critical infrastructure for the country. Now, the hallmark of these systems is that they are extensive, widespread, and expensive. So they consist of physical systems and cyber systems. They are expensive to build and maintain. For example, I'll take an example from the US. This US spends $3.6 trillion every year on healthcare, for instance. So this is 18% of the GDP of US, and this is more than the GDP of most countries in the world. So there's some background noise. So most countries in the world, like there are just 3 or 4 countries who are having GDP more than 3.6 million. So the US spends more than other countries' GDP on healthcare. So this is how the expenditure happens on critical infrastructure. So these systems, which are so extensive and expensive, if they are attacked and compromised, then it endangers the country's economy and people's health and safety. So these systems are taken care of, but they still face flack from people. And the reason is the expectations are high, and expectations are becoming higher with time. So what planners are doing is they're taking recourse to technology to improve the efficiency of such systems and reduce their cost. So what trends we see in this direction in technology is a lot of use of sensors to collect data from source. And since the data is collected 24/7, huge amount of data generated. For instance, when a patient is under observation, moves from home to office through the ambulance, goes through entire route, and then he's observed or she's observed 24 hours a day. Similarly, nuclear plants or power generation systems, waterworks, they are transportation observed 24 hours a day. So there are huge amount of sensors. For example, in the healthcare, the number of sensors per bed today are 13. So in the US, every hospital bed has 13 sensors at least. And then more specialized sensors could be used. They are placed everywhere on the body, inside, ingested, and so on. Similarly, on other things, the sensors are placed close to where the data is generated. And because the data is huge, recourse is taken to multi-cloud computation. So there is a trend to use not only one cloud, but multiple cloud, especially combination of edge clouds and core cloud to do computations fast in the edge, and also have the sophistication of the core clouds for analytics and storage. So we have seen that this combination works very well and provides a combination of low latency calculations for immediate use. And for if you want sophisticated AI type analytics, you have to go to the core cloud. The other component that is happening today in these systems is virtualization of communication components. So instead of using physical proprietary networks, virtual networks are being used increasingly, and these are instantiated over multiple clouds. So this is the kind of trend. But what problems do these pose? The problems that come in is with the use of this technology, as the sophistication increases, the possibility of attacks also increase. So this is the problem that we are facing. If the patient data is compromised or a nuclear plant data is compromised, either the health of the person is compromised or the safety of the country is compromised, and therefore the stakes are high. And we need to take care of cyber attacks in these systems, which are more than traditional networks. So what we have tried to do is we have tried to use, as the data moves from edge clouds to the core clouds, so we have we have tried to provide security to data in motion by using deep neural networks so that the data reaches securely to the core clouds and reaches back to the visualization domain very securely to the doctors, for instance, and operational managers or NOC for systems. Now, this is a simplified model hierarchical of the system that I'm going to describe. So this actually, any system you take, any critical system you take, this is something similar to this. So what we have is, we have an IT domain where the data is connected. So this could be healthcare or transportation or air travel or whatever. All these critical systems are observed, and huge amount of data is communicated to the edge cloud closest to the system. And the system that I'm talking about all through this is the system where patients are being carried from home to a hospital in ambulances, and a lot of data is collected from them. This data goes to the nearest edge cloud. Now you can imagine edge cloud as a mobile edge cloud where the computation systems are located close to the base station on the mobile network towers. So it goes to the nearest edge cloud, is processed for immediate use, information sent to paramedics, information sent to the hospital visualization centers, and then all this data is sent to the core cloud for deeper analysis and for storage and analysis along with historical data. The patient, when the patient goes to the hospital, it's the current data that is being taken to the edge cloud, but there's a lot of historical data of the patient available in the core cloud. So together, these two are analyzed, and more information is sent to the doctors so that when the patient reaches the hospital, all these streams of data could be collected and decision could be taken. Now, as we see here, it's very clear that there are a lot of attack surfaces. If you look at the interface between the edge cloud and the core cloud, you have gateways here, usually virtual gateways, and these are liable to attack. The attacks are, so every gateway between this and this and this and this look at two attack surfaces. So the gateway here is looking at this attack surface, which is very large, national, regional, or international. And it is also looking at this attack surface, which is fairly large. And this gateway looks at these two. So there are a lot of attack surfaces, and the fact that all these are connected, the clouds are connected to the internet, so they are all bound in cyberspace. Therefore, the attacks also become more serious and diverse and more in number. So this is what we need to take care of. And the problem, therefore, that we initiate is that data in motion across clouds, when it moves from IT domain to edge cloud to core cloud, it faces threats of cyber attacks. The problem here is that attacks are mostly unknown. So as we have observed from the attack data, those attacks have not been, most of the attacks have not been seen before. So the usual methods of detecting these attacks, even if we use shallow machine learning, they fail to detect these. And the reason is we don't have attack data available to train these models. So what we have is only the normal data as it flows 24/7 into the edge cloud and core cloud. We just have normal data. And with this kind of a data, it's difficult to train machine learning algorithms to give good detection. So the traditional methods don't work, and therefore researchers have been trying deep learning techniques in last 5 years. So when it started, people actually wrote off the deep learning techniques because the accuracies were low. But with time and better models and better curation of data and data handling, the accuracy has improved over time. And the algorithm that we have give fairly good accuracy. The other problem that we face is the training time. So the models in the core cloud are huge. The models on the edge cloud are smaller. So they're not very deep. So they could be like 3-4 layers deep. But models in the core cloud, because they handle a lot of data and analytics, they are deeper. Therefore, the training time in core cloud is huge. So our problem was to decrease the training time in the core clouds and still maintain the accuracy. And for this purpose, we have used these hierarchical models where you have increasing complexity models from edge, IoT to edge to core. And what we have suggested is that we use merge layer in the core clouds, that is, train the edge clouds, which are faster to train, use those trained layers in the core cloud and make the larger model in the core cloud, and you don't need much training after that. So the training is much faster in the core clouds if you merge the layers from the edge clouds. So
dear presenter, you have last 2 minutes.
all right, so let me just share the results. This is same model explained in a different way. I have explained the problem. We work on the metadata like this, inter-packet arrival times, etc. So we have observed that the accuracy the time has reduced to 34.7%, and the accuracy is still within 95 to 97, which compares very well with the existing methods. We have tried it on a number of data sets, especially the later ones, 2015, 2018 UNSW data sets, and the results are same. So this is the result for the training in the core clouds, where you see the epochs one epoch is forward and backward propagation. So you have about 50 epochs time taken for edge clouds. But when we use the layers trained already in the core cloud, even though the models are bigger, we see that within 5 epochs, it stabilizes. So the training is much, much faster with the merged models. So if you look at the times, as I said, even though the model used in the merged model is larger, the training time is much lesser. These are the other methods that researchers have proposed over the last 5 years, 4 to 5 years. And we see that initial methods, mostly they are actually working on older data sets like NSL, KDD, and so on. But we have used the UNSW 15 and 18, and the results are better or comparable to the existing method. So we find that when we use the merged models, the training time reduces, the accuracy is retained. So in future, what we are trying to do is, because these systems are critical, we are trying to build an understandability and transparency in these systems so that the decisions can be explained and the doctors can explain to the patients, or the operational managers in the nuclear plants can explain to the planners and higher ups that why these decisions are being taken. This will build the trust in the system. So this is briefly the research. If I know that this time is not enough to explain it all, but if you have a couple of questions, I can answer now. But my email is there, and then we could communicate offline. Thank you.
Yeah. Am I audible?
Yeah, sure.
Yeah,
Sure,
Dr.
Professor.
Gupta, nice work. Just I have one question. Can you justify why you have chosen deep learning here?
So as I said, that so basically we are facing unknown attacks. We see that in US, for instance, more than 75% hospitals have been attacked, and most of these attacks are new. So when you heard of WannaCry, it was not seen before. When you heard of PETIA, non-PETIA, not seen before. The hundreds of attacks that try to take over devices. So these unknown attacks are difficult to do.
Do you think that deep learning is only applicable for unknown attacks?
No, it's surely not. Deep learning.
Not at all. Not at all. Yeah, yeah.
Yeah.
So can you justify in one line why deep learning is you applied it?
Deep learning was applied because there was no other methods that we could see which will tackle unknown attacks. We found that known attacks can be tackled easily.
Have you tested that machine learning can do also same?
Oh no! So machine learning, they don't even recognize unknown attacks. A lot of them. So
not exactly. I can give references. There are so many.
Sure, we can discuss.
Yeah.
We did. Actually, everyone starts with machine learning. We started with a lot of machine learning models. Results were not good for these unknown attacks. Yeah, sure. No. You can curate the data and you can do a lot of stuff.
But that is my question is, have you performed any experimental analysis where machine learning could not do that? That's why you switched to deep learning.
Yes. So there are a lot of references. Actually, I've not mentioned here in my paper. They are mentioned. Many researchers have done those comparisons.
No, I'm talking about your work. I'm talking about your work.
We have used SVMs a lot, but the problem is the hierarchical nature of this. Now, when you use bigger models,
but what I personally feel, in your case, machine learning can do because you know the result you are presented, all are presented on normal machine, but deep learning.
No, because they are not. That's not our focus, actually, doctor. So, Professor, what we have done that 5 years ago or 4 years ago, a lot of machine learning on this, and the hospitals are not satisfied with the results, and we were not satisfied with the results.
Agree, Professor. But deep learning algorithms are to be tested on high performance computing. Either you have to use GPU or CUDA.
We did that. We use GPUs.
You didn't mention that.
Oh, because there are a lot of things in the paper which I have not mentioned.
Okay.
Actually,
yes, I wanted to clarify.
yeah, we did. So obviously, the models in the core clouds are large, and for training them, we have used GPUs as well. We have tried on smaller computers and GPUs and larger computers. multiple GPUs, more than one GPUs.
But I could not see that in your presentation. That's why
I'm sorry, I didn't. I thought
no issue, no issue.
So since I'm starting with deep learning, I'm presuming that this comparison of machine and deep learning and these things are for granted. So
no, it's okay. But
this is my assumption. I'm sorry, this is my assumption because researchers have been doing this in the last 5 years.
No, but the problem is, when we switch from ML to DL, we should rectify, because it's not always anticipated that we should always switch from ML to DL.
All right, so I'll make it a point. So in
I hope you agree with me.
I agree. So I agree.
Thank you.
Definitely, Professor.
Yeah.
So that's right. I can include that in my presentation. Thank you.
What happens nowadays, hope you will agree with me, because research in ML goes in, undirectional. People just take a data set, compare, prepare configuration matrix, and produce the result. I hope you are agree with me.
Yeah. So here, I know we had these problems. So I'm sorry to say, but in WashU actually there's huge machine learning. So I am PhD from Washington University in St. Louis, and
Great.
machine learning group, like about 30-40 researchers working on this, and we find that. So I thought, I took this for granted. So basically, I should have done it. So I took a lot of stuff for granted.
Being a mentor in this field, we always face this problem. Are you agree with me?
I think there'll be a lot of students listening, so I should have probably mentioned that.
Yes. No. Just I wanted to clear. But great work.
Thank you. Thank you so much.
I have another small question. As you are taking cloud and IoT, have you considered resource constraint into consideration? Because all IoT devices are having resource constraint.
So the main reason to go to the edge cloud is that all devices, IoT devices, most of them, if not all, the medical IoT devices are huge and some are not constrained. But other devices, you are right, most of them are constrained. So because power processing constraint, that's why the edge cloud is very useful. So you find that since I worked with the service providers, I'm a little familiar with the edge clouds. I know that we can get computations fast. You offload computation to the edge cloud rather than doing the devices.
Great.
Thank you. Sure.
Thank you. Thank you once again, Lav Gupta, for the nice presentation. Now I would like to invite our next presenter, Rosa K. Ahmed. Rosa, I had already unmuted you. Go ahead with the same.
Hello, everyone. Can you hear me?
Yes, you are audible. Go ahead.
Okay, thank you, and good evening. Actually, it's evening right now in Tallinn, and good time to everyone whenever you are. I just share my screen now. Okay, and you can see the screen, right?
Yes.
Okay, thank you very much. So let's start. My name is Roja, and I am originally from Kurdistan region of Iraq. I did my master's degree in UK in Newcastle University, and currently I am living in Estonia doing a PhD in e-court systems, and from Department of Software Science, Tallinn University of Technology. As you can see from the slide, our title for our paper is e-signature and e-court systems, with two more co-authors. I divided my presentation for some sections. I start with introduction, give you a brief introduction about the case study of the Kurdistan e-court system, and present what methodology we followed for our research, then present our findings and conclude by conclusions and some limitations of the research, and point to future direction. Before I start the presentation, I would like to focus that the goal, or emphasize that the goal of this research is to show the significant role of the electronic signature, which we call it e-signature, in the implementation of electronic court systems. This can be done through investigating the case of the Suleimaniye Appellate Court e-court system in the north of the Kurdistan region of Iraq. This e-court system is implemented as a first e-service in the Suleimaniye city. This is meant to be used as a pilot information system for future implementation of e-government in the entire region. So the results of this research aim to extend the body of knowledge and literature for academic researchers and judiciaries and other practitioners who are on the way to implement e-court systems. In addition, it aims to serve the decision makers in the Kurdistan regional government to draw their future plan for e-government implementation and address challenges in the early phases or early stages. So starting with introduction, we noted that worldwide there are many judicial systems have recently transformed their working processes from manual conventional systems to more digitized format through integration with technological tools in court and implementation of electronic court systems. These kind of electronic court systems or e-court systems aim to deliver more efficient justice services and present various benefits such as online accessibility, timeliness, transparency, and security, and many more advantages. However, entire paperless e-court system implementation means the full digitization of the whole workflow of case administration, starting from claim submission and ending by case disposal. So the whole phase, I mean, starting from case registration, generation of documents, hearing summonses, and all the processes, and their approval by court authorities need to be signed in electronic format. For example, case decision or court decision need to be issued by court and signed electronically with electronic signature by judge. So let's understand what we mean by e-signature. There is a good definition which I found presented by European Union Council on a thematic report on efficiency and effectiveness of justice systems. They defined it as a technological tool to be used in courts as a valid signature that is authentic, unforgeable, non-reusable, tamper-proof, and non-reputable. And in terms of category of electronic signatures, they distinguished between three main types of electronic signatures according to their security level. They started with simple electronic signature that there is no any evidence of the person who signed. And then the second type is called advanced electronic signature. Here, the higher security level exists and stronger connection with the signer. And the third type is qualified electronic signature. This one corresponds to the highest security requirements and contains qualified digital certificate and presumes a qualified electronic signature devices. So as I said and mentioned that these are categorized according to their security levels. In general, there are many people who use the term electronic signature with digital signature interchangeably, but in reality they are, or in practice, they are different terms. Electronic signature can be called to a simple electronic signature, where digital signature can be called to advanced electronic signature because it involves the digital certificate of the signer. However, in this research, we use the term e-signature to refer to the qualified electronic signature that is valid legally for courts, and it's equal to handwritten signature. Now, giving a brief introduction or overview about the e-court system in the Suleimania Appellate Court, the system has started to be implemented in 2015, and the aim of the system was to deliver higher quality services and better case management. The system already by now showing many improvements, significant improvements in respect to increased transparency. It has increased security of court cases, accessibility, case transfer is faster now, case registration and administration, and many more improvements. The system already developed with all necessary functionalities to assist court users in performing their daily operations more efficiently than previous manual system. The system allows collaborative activities to be held more efficiently. It has a central database and multiple participants can access the system at the same time. We have a portal for outside users that can access and get involved into cases. However, there is a lack of e-signature that is considered as the main challenge in this current system. For the purpose of this research, we used an exploratory case study design and multiple sources of data to strengthen the validity of the research. We used expert interviews with 11 users from the court side with different roles. We used personal observation and analyzed existing literature. Among the literature, we found out that Estonia can be used as an example as it's a very major country in implementing e-signature in their e-court system, and they have a fully paperless e-court system in action. We used Arcuda and as an instrument for our data analysis. So our findings are as the following. We found out that court users from different roles, they rely on a daily basis on a signature for processing tasks. We found out that signing process is currently manual in the current system because there's no electronic format of the signature. So we categorized the processes in general into 4 phases. It starts with case registration, hearings, then court processes, and case disposal. At every phase, there might be one or variety or multiple documents generated from the system that need signature from court authorities. At the moment, we found out that every document generated needs signature has to go through 3 steps of process. The document has to be generated from the system, printed on paper, signed manually, and scanned back to the system. We also found out that many literature supports our result that availability and validity of the e-signature is an essential issue to ensure security, integrity of the document. In addition, it saves time and cost for the court and ending up at a paperless system. It's also possible to use multiple methods or multiple channels for signing. We noticed that from statistics from Estonian court system, they showed that 25% of signatures are given using mobile ID cards and 75 used signature being given using ID cards. It means that according to different needs of the user, multiple methods can be applied for signing. Estonian practice also confirmed that availability of e-signature makes the case processing faster. As we see from the slide that from 2013 to 2019, cases days are dropped and they saved a lot of time, 30% of the time with using electronic signature. So in our conclusion, we confirm that availability of e-signature in the e-court system is an essential feature to ensure cost saving, faster processes, and increase efficiency and effectiveness of the courts. It ensures validity of the electronic document to be equal to paper document, and also ensures the security, authenticity, and reliability of data interchange in the system. Some limitations can be considered in terms of implementation of e-signature is that there is an absence of required infrastructure in the Kurdistan region for e-government or implementation of electronic ID and e-ID, electronic identity management system with valid signature. There is also a missing legal regulation and legislations to establish the requirements for electronic signature and equates electronic signature with handwritten signature. Therefore, we planned to have a future direction toward a study with detailed technical legal analysis to analyze different technical solutions that can be considered for implementation of this ecosystem. This is, of course, depends on the knowing needs and expectations of the board users. Here are the references I have used, and this is my last slide. Thank you very much for listening. Sorry, I apologize if I was being too fast. I tried to present all the slides, and if you have any question, I am glad to answer them.
Am I audible?
Yes.
Aman sir, am I audible?
Yes, sir.
Yeah. Any question from audience?
I think so. They have a question, then they can directly write to the chat.
Okay, that's good. Roja, nice presentation. I have very small question. You know, nowadays we are in era of IoT, where we have all devices which are resource constrained. So can you just focus on how this e-signature can be adapted to the devices which are resource constrained? Because nowadays we have all devices which are limited power, limited computation, limited battery.
Well,
Yeah.
actually, there are different technologies at the moment available to implement variety types of e-signature. But this research particularly actually focuses on the area of Kurdistan region, where this area can be considered as one of the non-developed countries.
Yeah, I'm agree. But I think being we are now into this ubiquitous computing, anything, anytime, anywhere, where all devices which we are carrying, we have all devices with limited all constraints. We have limited power, limited battery, limited even processing, right? So I think this e-signature will not suffice this all requirements. What do you think? Can you comment on
Well,
this?
in terms of this particular research, we think that the e-signature will help the current system to make it more efficient and more effective.
Can you just go back to this digital certificates? You know that digital certificates are not compatible with mobile devices. So do you have any comment on this?
Sorry, go back to where?
Digital certificate, all security certificates.
Digital certificate. Okay.
Yeah. These are not compatible with our mobile devices. You know that because these are made for all desktops.
Yes,
That's why,
we can sign with different methods actually. This slide you meant.
Yeah. Same
Okay.
thing. Yeah.
Okay, what's the question? Sorry, on this
My
slide.
question is now our mobile devices, because everyone is carrying all our transactions from our devices, smartphones.
Right.
Yeah.
Right.
And on smartphones, our digital certificates are not compatible. So, do you think that e-signatures will be compatible with our mobile devices?
Well, it depends on the type of implementation of the specific
that
technology
is what,
you select.
Correct. So that is what I would like to come to the point, because we need lightweight implementation.
Exactly. So it depends on what you select, and you accommodate it with the environment that fits with this technology.
Correct.
Yeah.
Yes.
So
do you have any future plan? Because nowadays industries are also doing mistakes. They are looking at this all IoT as
sorry, your voice is cut.
The implementation, but implementation is not. Yeah. Hello.
Sorry, can you repeat that? I didn't hear part of.
Yeah. Can you hear me?
Yes, now. Yes.
Yeah. Nowadays, all industries are already diverted their business to IoT.
Right.
Yeah. But they are doing mistake. What mistake they are doing? They are just looking at it as the implementation. But the implementation is not important. What is important is that how existing how existing algorithms will extend to IoT, because none of the security algorithm which is present is extended to IoT. Are you agree?
Yeah, I agree with you. And I would like to add a comment that technology
Okay.
might not be perfect for every situation
Yeah,
all the
yeah.
time.
Correct,
It
correct.
might has some disadvantages as well,
Yeah,
and
yeah,
it might doesn't fit all areas and
yeah,
every
yeah,
domain. So
yeah.
this needs a detailed analysis and needs
Correct.
a
Yeah,
plan and
yeah,
strategy and so
yeah,
on.
yeah, yeah. That is what I would
I
like to.
agree with
Yeah,
you.
yeah.
Yeah.
Perfect.
Thank
Perfect.
you.
Thank you. Thank you. Good
Okay,
luck.
thank you.
Good
Thank you
luck.
very much. Thank
Good
you.
luck.
Thanks
Good
for
luck.
everyone. Bye.
Thank you, Rosa. Thank you so much. Now I would like to invite our next presenter, Urja Makar. Yes, Urja, go ahead.
Okay. Good afternoon and good evening to everyone present here. Am I audible to everyone?
Yeah. Please.
Hello.
Please.
Okay. Uh, so here I will be presenting myself, Professor Urja Makar. I am a research scholar. My research area is IoT. So here I will present a study for open source framework, that is OSGP, for implementing smart water metering application. Okay, so this is the agenda. I'll explain what are the different areas where IoT can be implemented, what is our research objective. Then I'll be introducing smart metering and why we need a framework for implementing smart metering applications. And we have studied an open source framework, so I'll be discussing that framework and will conclude. Okay, so as we all know that IoT technology is widely used in different sectors like healthcare, agriculture, education, and industrial, and many more. So the countries like India, the developing countries, are facing a water scarcity problem as a major issue. So we are studying on the smart application which can help to manage those resources, the natural resources. Uh, we found that the smart water metering is one of the upcoming application of IoT. So in a smart metering, there are network of meters connected with computers, mobile phones, or any other operating devices, and these meters are giving us the reading. That reading are sent to the utility suppliers, and from that data management can be done, and from the utility suppliers the meters can be managed. So for performing all these smart metering applications, we found that there are some key challenges. There are n number of devices are there, different proprietary meters are there, then different types of utility suppliers are there. These devices have different types of communication protocols, and they have different connectivities and data transmission mechanism. So to combine everything on a single platform, they require a standardized framework so that we can connect all existing meters and can communicate using different types of communication protocols, and can allow different types of existing meters to send the reading, the uh, water usage reading to the utility service providers. So why we require a framework? Because it will give us a platform where device connectivity will be there, device communication will be there, uh, where we can apply different protocols for communication and connectivity. That framework will reduce the cost and complexity of development. Because in IoT we have seen that n number of devices are there, they all are resource constrained devices. So how the network is working right now, exactly same network configuration might not work with different types of devices, because these are the heterogeneous devices. So if we get a framework so which will be standardized, which will help us to develop any smart applications, and which will also allow us to customize, means a framework which will be able to give us the customized solution for smart water metering, for electricity metering, for smart lighting, and so on. So here is the study of the open source framework. There are n number of frameworks available in the market. They are the proprietary solutions, so they are very costly and we cannot customize it. That is the main drawback of using a proprietary framework. They are costly and cannot be configured or cannot be customized according to our need. So there is an open source framework uh, which will allow the communication between heterogeneous devices, can also support the physical infrastructure, communication protocols, data management, and we can have the different types of user interfaces also. Previously, the name was Open Smart Grid Platform, which is an IoT platform. Nowadays, it is known as the Grid Exchange Fabric, which provides a common infrastructure for multiple smart applications, and it enables controlling and monitoring of various smart objects connected in the public space. It has built-in operations like privacy and security for data exchange, interoperability with alternative standards, and ability to integrate other non-smart grid devices. So these are the features of a open smart grid platform. So here we would like to discuss the architecture framework of architecture of this framework. So this is a layered architecture. 5-layer architecture is there, where the topmost layer is the domain web service layer. The domain web service layer will expose the functions to the platform, and which will connect different devices in the network. It provides two types of basic services: core services and the domain specific services. Each function domain will have its own web service. We can here add our own web services also. It gives us the feature to design our own web service for our own devices to be communicated using this platform. So it is using basically SOAP. Communication as is done with the SOAP, Simple Object Access Protocol. Then we have this domain logic layer. Domain logic layer are basically the functional domain where the basic business logic has been implemented, and there are domain adapters which will adapters will accept the request from the web service and forward it to the platform functionality. So the platform main functionality are under the core functions layer, or you can say the core functions. Some basic functionality has been provided by the platform. We can add more functionality also. So core functional layer has uh, been providing with the authorization, validation, translation, route request messages. Everything is done by the core functions layer. Uh, so it also gives the basic functionality like device management, means we can add, update, delete, configure our devices from the utility service providers. Then firmware management, time synchronization, and many more functionality has been implemented in the core functions layer, and we can add further also. Then protocol layer.
Last 2 minutes, dear Urja.
Okay, protocol layer. It is basically the protocol depending upon the devices. It translates the application level messages to the device protocol. It is providing the listener for the devices. And finally, there are the devices at the physical layer which can be connected to the internet. And this is the communication sequence where first is the web service adapter. these are the different components where message flow.
I think, Uja madam, can you
Yes.
conclude, please? Yeah, please conclude.
Yes, sir. Okay, so this is the last only flow sequence diagram where different components are communicating in a sequence. So first of all, the web service adapter will receive a SOAP request from the client. Then it will authorize the client using the organization ID. Then it will pass that request into the request queue. Then the domain adapter will pull the request queue, and the domain adapter gets the response from the request queue. It will pass it to the core service layer, and from that the protocol adapter will send the message to the devices, and then it will get the response from there, and the client application pulls this response queue from the web service adapter using the correlation ID. So this is all about the OSGP framework, but it has some limitations that it is using RC4 algorithm, which is not much more secure as it is using the known IVs. It has weak digest function. So whenever the firmware update messages are broadcasted, they are not securely broadcasted. Session key is also same as the master key. So there is the security issues in this OSGP. So we have concluded that OSGP is best suitable for the reliable communication, multiple types of device communication, and so on. We can develop our own smart applications using this framework platform, but we have to add some improvements like security in the communication and broadcast messages. Thank you.
Any question from audience? Yeah. Urja madam, I have one very simple question. Can you differentiate between framework and architecture?
Yes, sir. Framework has got its own architecture where
one of your slides says framework architecture.
Okay,
one of your slides, yeah. Can you go to place that slide?
Yes.
Yeah.
I'm
please,
good there.
Yeah. So I don't understand framework architecture.
So this is the open source.
Can you go to the slide, please? Can you go to the slide?
Yes,
please. Yeah.
Actually, Urja, your share screen is off right now.
Yes, sir.
Yeah, I don't understand framework architecture. So both words are coming together. Yeah.
Yes. So this is the framework which I'm talking about.
No. My question, please listen to my question carefully.
Yes, sir.
My question is, how can you combine two words, framework architecture?
Okay, here I would like to say that this framework has got some basic components and the layers. So
I think you should use one word, either framework or architecture. You should not combine these two words, framework architecture, because just can you tell me the difference between organization and architecture?
Organization has got an architecture.
Yeah.
Yes.
Yeah. So same goes here. I think this is misleading the slide. Right?
Okay.
Yeah. Framework architecture doesn't suit here because what we are presenting is architecture or framework. It is not clear.
This is the architecture design of how this framework is working, how this framework allows
I agree, but there is a difference between framework and architecture. Framework is high level. Yeah.
Yes, sir. So this is the framework. Yes, this is the framework having 5 layers.
Yes, this is not architecture. Yes, this is not architecture. This is framework. Right? I hope you are agree with me. Because this is somewhere it is misleading your presentation, because architecture is deep.
Okay.
Right? This is framework. So don't combine these two words, framework, architecture.
Okay.
Just one suggestion.
Yes, sir. Thank you for the suggestion.
Yeah, nice work. I have another question, that
Yes.
when this is just a high level idea you have presented. How will you implement it?
I'm working on this web services and I'm working on this protocols. So for meter communication and number of protocols are there. I want to add specific water meter protocol with this framework for the metering communication, and developing own web services for communicating through the mobile phone to our meters.
Do you have any idea about restful and restless services, restful services?
Yes, sir. Yes, sir.
So what is your idea? Restful or what services you are looking for?
We are looking for the RESTful services. We are using basically MQTT protocol for the communication.
Do you know MQTT has lot of frauds because MQTT pass their messages without encryption.
Yes.
Yeah,
So
so better you can go for what is replacement to MQTT? COPE. COPE is best.
oh yes, sir.
Yeah, you can go for
Yes,
COPE.
sir. Sure, sir.
MQTT has lot of drawbacks because they transfer message between them, sir, in open media.
Yes, sir. Yes, sir.
Yeah, so you can go for COPE. Don't go for MQTT.
Sure, sure, sir.
Okay.
Sure, sir.
All the best.
Thank you, sir. Thank you, sir.
Okay.
Thank you. Nice to meet you, sir. Thank you.
All the best.
Thank you.
Good
Thank
work.
you, Ulja.
Good work.
Thank you for the suggestion, sir. Now I would like to invite our next presenter, Nandish.
Aman sir, this is last but one.
I think so. Vidya has joined also, so might be it is a second. So
Okay.
second presentation it is. So Nandishwar, you can go ahead with the kindly.
Yes, thank you. I think I'm
the
audible.
time limit also.
Am I audible?
Yeah, you
Yeah,
are audible.
yeah.
Yeah, thank you. Yes, sir. Myself, Nandishwar SB. I'm a research scholar in Presidency University here in Bangalore, India. And I also work as associate professor in an engineering college, that is APS Engineering College in Bangalore. I'll just share my screen here.
Yeah, please.
Okay. Okay. I have started research on early detection and grading of diabetic retinopathy using ensemble learning algorithms. I chose ensemble learning. I'll be explaining about now how actually I came into this ensemble learning later. This will be my plan for today's session. I'll go through my introduction and some of the literature review that I have gone through, and about ensemble learning and a proposed model, in which I have used for comparison for different parameters, of different learning algorithms, how they perform on the same set of data that I have taken.
Sir, you can skip this. Please go ahead.
Yeah. Okay. Thank you. We have this data about about 93 million people suffer blindness because of this diabetic retinopathy, which is the main cause. And the reason for this is this swell and leaking of blood into the very smooth nerves that are around the retina, and this causes a lot of damage to the retina, and in turn turns into blindness. Now, how can this be avoided? Now, only thing is we need expert people who can take images of retina, detect it early, and inform about this to the patient regarding what they are developing into. That will not be possible in countries like India, where in the rural parts will not have enough expertise. So if we can think about developing some tool wherein in the absence of experts like doctors and surgeons, it can to certain extent take the the role of doctors and determine whether the patient is developing diabetic retinopathy or not. So artificial intelligence is one area which is majorly used for predictions nowadays based on the data given. using this, we initially thought of now machine learning algorithms. We came up with machine learning algorithms. We thought of running data on machine learning algorithms, but we had a problem of machine learning algorithm getting biased for little amount of data that is available in the country. So when I ran around different hospitals, eye hospitals, and doctors, spoke to doctors, they gave me one clean suggestion saying that, boss, you're not going to get data. It is very confidential. So if you have data, it will be very much limited. Now, having limited amount of data with us, we can only go for such algorithms which will be giving more accurate results with small amount of data, right? So in that case, single machine learning algorithms may not be because good at this because of the biasing they do. The second thing is, if we go for deep learning algorithms requires a large amount of data set to give a better accurate result. Now we thought of, why don't we combine, instead of, no, we don't have a data set here, good amount of data here. So we thought of combining one or more algorithms, machine learning algorithms, into good predictive models. So then came up with this idea of ensemble learning algorithms, which are already now had some kind of people who had gone through these. They have used good industry running algorithms like XGBoost, AdaBoost, stacking algorithms, all such algorithms which are performing very, very well in the industry. So I went through a lot of papers like this, few papers, and I came up with best industry driven algorithms and best practices which have been adopted in industry to use these algorithms with the available data set. And when I went through this ensemble learning, the basic idea here is to use a diverse set of classifiers which can improve the performance of any single individual classification system. Now here what we have done is, we have made use of classification techniques that we thought of we will be getting good classification accuracy. And we chose 3 algorithms like stacking algorithms, which in turn will be using 4 more algorithms like KNN classifier, decision trees, and such 4 more algorithms. And AdaBoost algorithms, one more again, which uses both bagging and boosting as a ensemble classifier. And the most important one was the XGBoost algorithm. And we thought of comparing these 3. Which one would perform better when compared. Now for this, we chose some of the performance metrics like accuracy, F-score, and AUC, and precision score. Now when we took all these into consideration, we had one data set, and that data set was to be subjected to all these algorithms one after the other and check the performance. Now we proposed a model like this. We came up with a model like this, wherein the data will be first pre-processed, will be brought into one a particular dimension, and the data set was completely very confidential. We had to deal with that. Again, we took it like the images were fundus images, and those images were to be pre-processed, and then we only decided to take the statistical features, and that too basic features. I was just starting with my research, so I didn't wanted to jump into advanced or something like. I just wanted to start with the grassroots level. So I started with basic features to be taken, very few features to be taken, and after that I thought of, okay, if we consider few features, and if we start extracting those features from each image, I may get a lot of features, right, for those basic features. Now for those basic features, if I have a lot of features, how I would do a dimensionality reduction on that. So I came up with one more tool which was available, that is a VCA tool, using this CFS mechanism which is available in it, that is correlation based feature selection method. I reduced it again and subjected those collected data which were earned from these images into all these algorithms which are available, which are shown here. That is the stacking algorithm, which uses KNN with a K value of 5, random forest, neighbors algorithm, and stacking classifier again as an aggregator here. Now again, we had a AdaBoost algorithm which will be monitored. And you see these three algorithms on the above are shown with the features which are not subjected to CFS. That is not no dimensionality reduction. Original features, what we have got, the number of features that will be used, run on these algorithms. And in turn, again, the same data set will be subjected to a CFS. Reduced features will be again run on the same algorithms, and both are compared here to check which is performing better on one another. Now, the experimental setup was like this. We took images of size, initial size of the 576 into 720 pixels, and we started localizing and collecting the statistical features. So why we go for more the localizing, we get more accurate features. So that is a known thing. In this proposed work, the fundus images were divided into sub images, localizing into 36 into 90 pixels. We divided the entire image into like that. Statistical features such as basic features such as mean, variance, skewness, and kurtosis of these subdivisions were taken, and each of those we got a vector size, feature vector size of 512 features. Each image now had 512 features, right? So those were the original features. Now then came this feature selection, dimensionality reduction method. We chose VCA tool and correlation based feature selection in it. It's a simple filter algorithm that ranks feature subsets according to correlation based heuristic evaluation function. The bias is towards subset that contains features that are highly correlated with the class and uncorrelated with each other. So this CFS does this for us. So we got these features, reduction in dimensionality. The acceptance of a feature will depend on the extent to which it predicts the class in areas of instance space not already predicted by other features. So this was the reason why we selected CFS in VCA tool. So finally, these features, 512 features were reduced to 47 features when we subjected it to CFS. Now, we had two sets of data now. One, an image having 512 features, and the same image with 47 features, considered to be very important features for that image. Now, with these two, the data was collected like this in CSV format, and the same was run using the Python programs and libraries that are available on Python. We started running the 90 samples. We had only few samples, so only 90 samples subjected to collecting features with or without CFS were considered for our experiment. Now, when we run the program, we observed that 90 samples with 512 attributes, that is original without any CFS, yielded these results. When we look at stacking algorithm, it was no way a go here. No,
because, Professor, can you conclude, please?
Yeah, AdaBoost algorithm gave us the result to be more accurate, more improved result. When XGBoost, in terms of accuracy score and F1 score, was considered to be good, and we can see the ROC which was constructed here for those results, and this result was only for the data which was not subjected to CFS. When we subjected the data to features reduced, we had only 47 attributes, and these 47 attributes for the same 90 samples yielded these results. Now with these results, we saw again the AdaBoost algorithm was doing better for area under AUC value and the precision score value. But when we look at the accuracy and F1 score, now this stacking algorithm was doing good. Now these comparisons led to draw some conclusions. Now the conclusion was like this. We emphasized on evaluating the performance of most preferred ensemble algorithms in industry today. And the key performance metrics were chosen and algorithms recorded with the same magnitude of data with or without CFS. We observed that AdaBoost classifier outperforms other classifiers with dimensionality reduction without dimensionality on data by proving 94% and 94.6% precision score. Whereas XGBoost classifier has an edge in case of parameters like accuracy and F1 score with 87 and 83 respectively. it is a common belief, we all know that whichever algorithm comes up with good accuracy and F1 score, leads the way. So here we can say for this amount of data, what we had, XGBoost classifier has done well in terms of accuracy and F1 score. And in case of this CFS, what we adopted here is not very advanced one. It was a very basic one. Now I prefer we taking up more features, means extracting more features from the image using more advanced methods, and an advanced dimensionality reduction method may lead us to a better result in case of using XGBoost. So that was my findings in this work, sir. Thank you.
Aman sir, any question from audience?
Yet not, sir. You can go ahead with your comments.
Yeah. Professor, I have one very basic question. You know that ensemble method always puts overhead, because ensemble method combines multiple techniques.
Yes, sir.
So have you taken into consideration that?
Yes, sir. Of course.
Ensemble. Because you are not because when we go for ensemble,
sir,
ensemble is basically combination of multiple methods of ML into
yes,
one technique.
Correct, sir. Hello? Hello?
I think so, sir. Internet is unstable. Yes, Mahale sir, are you there?
Hello? Sir?
Nandeshwar, we can hold for 1 minute.
Yes, sir.
So there is a due to internet connectivity issue.
Yes, sir.
Might be, sir, I was some issue. We can just hold for 1 minute to reconnect him.
Yes, sir. Yes, sir.
Yes, he is available right now. Mahale sir, you are muted actually. So unmute.
Yeah. Am I audible?
Yes, go ahead.
Yeah.
Yes, sir,
Professor, when we go for ensemble method, you know
yes,
that when we combine multiple methods together, so
yes,
you didn't focus on that overhead.
Sir, if you look at my proposed model here, the stacking algorithm which I have mentioned clearly makes use of different algorithms, a combination of set of
ensemble. Actually, that is a concept of ensemble. Ensemble means
right.
We combine multiple methods, right?
Yes, sir. Yes, sir.
Yeah. So
this
you should
AdaBoost, XGBoost are inbuilt ensemble algorithms which
What
makes
about isomap? Isomap also very good.
I have not considered that, sir, for time
Yeah,
being. I'll
then,
definitely take your suggestion on that.
Yeah, isomap is better than XGBoost and bagging. Have you considered bagging? No.
Yes, sir. Both the bagging and boosting.
Yeah, then you should go for isomap.
Isomap.
Yeah.
Yeah.
Isomap will give you better result. And when you go for ensemble,
sir,
you should first justify why you are going for ensemble approach. Because
yes, sir.
Because ensemble always put overhead.
Yeah, okay, overhead.
Are you agree with me? Just this is a discussion. Ensemble means combining multiple methods together. Are you agree?
That is right, sir. Yes, sir.
Yeah. So ensemble always put overhead, and we should consider that into implementation.
Yes, sir. I agree. Totally agree with you.
Yeah. Actually, ML itself is a overhead, and then we are going for ensemble. Ensemble means combining multiple methods together.
Yes.
Are you agree, Professor?
Yes, sir. I do agree.
Yeah. So please take this suggestion. This is for your further improvement.
Thank you, sir. Thank you so much.
Aman sir, any question from audience?
No, sir, not yet. So thank you, Professor Nandeshwar. Now I would to our last presenter, Vidya. Yes, Vidya, are you there?
Yes, hello?
Yeah, go ahead.
Yeah, am I audible?
Yes, you are audible.
Yeah.
Okay. evening all. Hello, I'm audible?
You are audible, Vidya. Go ahead.
Yeah. My topic is response time analysis of dynamic load balancing algorithms in cloud computing. So I'm from KLE Technological University, Hubli. This topic was chosen because there's a lot of significance arising due to the advancement in the field of networking, which has led to the large-scale distributed and parallel computing systems. So cloud computing is a distributed system which has emerged in the few years before, and it is a very good technology and emerging technology because of its kind of services it provides, like servers, data storage, network services, applications. Because of this, cloud computing is an emerging technology. And one of the aspect in cloud computing services is the data centers, which are made available to many users over the internet. And data center network is the interconnection of the data center resources. And in order to connect all of these data center resources, the data center network must be very much efficient, and it should be scalable to handle the increasing loads of the cloud computing. And this, in order to handle the increasing loads of cloud computing, it has led to the concept called as load balancing, which is an issue in cloud computing. So load balancing, it's a technique which is used to redistribute or distribute the user request to the virtual machines, and it is to relative to the capability of the individual virtual machines. Here what we are considering is the virtual machines are of different capacities. They are different in their speeds, they are different in their memory. So to properly utilize all the resources in the data center networking, load balancing is very significant. The main objectives of load balancing are to maximize the utilization of the cloud resources such that the throughput and the resource utilization are maximized. That is, resource optimization is one of the important aspects to minimize the job response time, and the starvation of small jobs should also be prevented through load balancing. This presentation includes three different algorithms, like a throttled algorithm, equally spread current execution algorithm, and an algorithm which is based on nature inspired algorithm. So this is the throttled algorithm which is considered for load balancing, and these are the load balancing algorithms which are used for load balance dynamically. This consists of n user bases, that means large amount of requests from the users which need to be processed by several virtual machines. So this algorithm works in such a way that there is an allocation table which is maintained by each virtual machine, and initially all these virtual machines are assumed to be available for processing the request. So whenever there is a request appears, or whenever a request is received, then the data center checks for which are the virtual machines which are available for current execution of the request. Whenever a VM which is available for processing, so that is allocated for the request. Otherwise, whenever a VM is allocated, its state changes to busy. If none of the virtual machines are available for allocating, then the tasks have to wait in a queue. This is throttle algorithm, dynamic load balancing algorithm. Another algorithm which is considered is equally spread current execution. So this is similar to the throttle, but however here the number of tasks assigned to each of the virtual machine is stored in the allocation table, so as to maintain the number of tasks equal on all the virtual machines. But however, here what we can see here is that even though the virtual machines are able to take up the task, but they will not be assigned the task because of these drawbacks. Like virtual throttle will take up only one task at a time. Until it finishes the task, no other task will be given. And this algorithm, equally spread current execution algorithm, maintains equal number of tasks over the virtual machines. Then the bio-inspired algorithm called as the particle swarm optimization algorithm is tried out for checking how it balances the load. So this is based on the swarm. This is a swarm intelligence algorithm, which is based on uh, which is based on the swarm, on the behavior, how the birds are going to look in for their food. So there is a group of birds here which are going to adjust themselves with respect to the position and velocity where the food is available. So in each iteration, each one of the bird is going to, here bird in the sense each task is going to try to find out where the food is. Here according to this algorithm, the food is nothing but the resources. The resources are in scarce, but the tasks are more. So finding an appropriate resource for each task is done by the particle swarm optimization. In each iteration, every particle finds a position. It adjusts its position and velocity with respect to the food. And in each iteration, the position best and the velocity best are computed. So that will be the fitness function here, is to uh, find the assignment of the task to the virtual machine, which will provide the minimum execution time. So this is the basic particle swarm optimization, which is used for study purpose. The simulation is carried out using the CloudSim simulator with homogeneous and heterogeneous resources. Here what I want to focus is on heterogeneous resources, because all the resources are of with different speed and memory capacity. So we want to exploit the complete full utilization of the resources. So the configuration has the three different parts, like main configurations and the user base characteristics in the cloud sim simulator. The main configuration is used to configure the parameters like the number of user bases, the service broker policy. The user base characteristics is used to represent the group of users, that is to create the traffic. And the Poisson distribution is used to randomly vary the number of users. That is, so this is, since it is a dynamic load balancing, so the distribution of the traffic should vary randomly. The data center configuration includes the parameters like data center, how many data centers we have, what is the region, architecture, what is the OS it is using, and number of servers. Data center controller is used to manage the cloudlet request, routing, creation, and destroying of the virtual machines. And the virtual machine characteristics include the virtual machine unique ID, image size, memory, and bandwidth. So data center parameters, these are some of the parameters which are used for data center. So here mainly what we are focusing on, the number of processing elements are varied with the simulation. The processing speed of the virtual machine is varied. So when the experiment, when the simulation was carried out with homogeneous set of resources and heterogeneous set of resources, we have encountered that all the three algorithms will behave in the same way. Almost the response time. The response time is calculated as the time for the request assigning to the virtual machine and the time taken to reply to the client. So this overall time is called as the response time. So the three algorithms are similar way in the homogeneous, but in heterogeneous, we find that the bio-inspired algorithm is performing better because it has the capacity of adjusting itself when the requests are going to change, because we want to exploit the resource utilization completely. Because the resources are heterogeneous, the speed and the memory are different, so we want to optimize the resources. So swarm intelligence, because of their capability of self-organizing, so they are able to find out and give the better response time. So we have got that the in heterogeneous mode, the swarm intelligence or the particle swarm optimization, this is a basic particle swarm optimization PSO, which will provide us better response time. And to conclude, it's an important issue in cloud computing nowadays. And the demand for this cloud computing is growing with the increase in the size of applications and increase in the number of users, because of which there is an uncertainty in the traffic. The available resources must be utilized to exploit the capabilities of heterogeneity. Otherwise, it leads to underutilization of the resources. And to maximize the utilization and to reduce the response time of tasks, load balancing is essential. So here this article involves a comparison of the different dynamic load algorithms for homogeneous and heterogeneous network. And due to the adaptability of the dynamic changes in the user band and variations in the network, swarm intelligence can be applied to handle the uncertainty. And these are some of the references. Thank you.
Thank you, Vidya.
Yes, sir.
Sir, any comments?
Yeah, I have, Vidya madam, I have one question. Can you
Yes, sir.
precisely differentiate between homogeneous and heterogeneous resources actually?
Yes, sir. So homogeneous resources are the one which have the same architecture, same speed, and the same amount of memory. Heterogeneous resources are with different OS, different operating system, different architecture.
Yeah. So in your implementation, implementation, can you just precisely differentiate between how this configuration varies?
This varies with respect to only the virtual machine, the number of virtual machines and the processing speed. I have considered only with respect to change in number of virtual machines and the processing speed. Speed of each VM is different, and the number of processing elements in the data center server is different for heterogeneous. For homogeneous, all of these factors are kept constant.
Okay, so in your implementation, have you taken into this homogeneous? All machines are with same
Yes, sir.
speed.
Yes, sir. Yes, sir. With the same.
How many machines you have taken for implementation?
Virtual machines are say around. I have varied, sir. This is an average of all. The result is
can you go to that graph, please? Can you go to that graph?
Yes.
Yeah. So in this graph, you have not mentioned how many machines you have taken into consideration.
Okay, because I have varied the number of virtual machines every time when I simulate and run, and I have taken the average of all of these simulations.
It's okay, but my question is, can you tell me how many machines you have taken into consideration? How many machines you have taken for implementation?
Data center was 2.
No, my question is very simple. My question is very simple.
I got your question. So number of virtual machines I have varied with like 5 virtual machines.
No, you are not varied. You are not varied here because your graph doesn't show you are varied. So it is fixed.
It speaks only about the response time of these.
So can you tell me how many machines?
Yeah, I have noted it. I have mentioned it, but here I did not. Okay, processing elements, if I have, say, for example, 2, I have taken some 5 virtual machines.
Madam, can you go to that graph? My question is very simple.
Yes.
My question is, how many machines you have taken into consideration?
Say 5 virtual machines for one processing element.
5 virtual machines?
5 virtual machines for one processing element.
What do you mean by processing element?
They are the part of the data center, sir. Each processing element further has.
So this graph is same for both homogeneous and heterogeneous. Only 5 virtual machines are taken.
For homogeneous, but it is the same for heterogeneous, but with different capacity of virtual machines.
It's okay, but you have only taken 5 virtual machines.
Yes, sir. Yes, sir.
Do you think you are saying that it is scalable? 5 virtual machines are enough?
It could be. It can be scaled up. It has to be scaled up, and it can.
I think for your solution it should be scaled up.
Yes, sir. It has to be scaled up for
it has to be
more virtual machines. That consideration. Yes, sir. I would like to. I will take it.
Please. Huh?
Yes, sir. I will take it. Thank you, sir.
Thank you.
Thank you, Vidya. Thank you.
Thank you, sir.
Thank you, Parikshit sir, for the valuable comments. Now I would like to invite Dr. Amit for the closing remark of this.
Amit sir,
Hello, sir.
namaste.
And all
क्या
present
बात है,
here,
क्या बात है,
and
क्या बात है.
it's amazing to see you.
Same
Uh,
here, same here, same here.
Parikshit sir, thank you very much for sparing your valuable time. In India, it's almost around 10:40 in the night, so
No,
it's
no
really
problem,
great to
no
have you at this
problem.
particular moment of time, and
Thank you.
look forward to your association and your collaboration and your support in future conferences.
Always,
And
always, sir, always, always. Nice to see you. Nice to see you.
And I'll request Aman to share a certificate of appreciation.
क्या बात है, क्या बात है.
And thank you very much. My next thanks is due to all the participants who are present here, who have taken a valuable time to present their work. Two
Yes.
things, just to basically, I want to tell you that regarding the publication time, it will take another 2.5 to 3 months to publish your papers in IEEE Explore.
Yeah.
We have already sent the data, and e-copywriting has already been done. Those who have not done yet e-copywriting, they will be getting the mails in 1 or 2 days. So please be patient at that till that time. And if you have any queries, please drop us a mail. We will be happy to support you in any possible way. Second thing, you will also receive your certificates, your payment receipt, and a thank you letter from our organization. Once the session is over, or maybe in couple of 1 or 2 hours, you will receive it. So thank you very much, and I hope that you all stay safe, and we will again overcome this pandemic, and COVID-19 will soon be a thing of past, and we will meet for our next physical conference soon in 2021. Till that time, stay safe and stay blessed. Thank you.
Aman sir, bye bye. Amit sir, bye bye. Chalo, good night.
Bye, sir. Good night.
Good night.
Once again, thank you to
Stay
all.
blessed, everyone.
Thank you.
And if you are in Europe or if you are in London, enjoy your time because it's summers.
Yes. Thank you. Bye.
Thank you.
Good night.
Once again,
Yes.
thank you, Parikshit sir. Thank you.
Arey, thanks. Yeah.
Fine.
Bye. Bye.
Bye. Take care. Stay safe.
Bye. Bye.